Hi, this is the final video for the lesson 3.4 or unit 3.4, solving problems using right triangle trigonometry. And so this problem is relating trigonometry to the coordinate plane. I bet you're excited about that. But it's actually really easy because the angle, it says find the angle between the x-axis and the line y equals 5/4 x minus 6. So I have here, there's the line, this is the line y equals, this line right here, is 5/4 x minus 6. So the angle, we're actually kind of looking for this angle right here. That's theta. Okay. We could look for the other, in fact, we could do both angles, but right now we're just going to do the acute. I probably should have said the acute angle between the x-axis and that line. Okay, now that angle right there, because it doesn't matter if we're doing it between the x-axis and that line, but why don't we do it right here as well? So this angle here is also going to be theta. All right, we know that the slope equals 5/4, which means in this triangle, if I do, so this is rise over run. So the run from this point over is 4 units, so we're running well, any multiple of 4 units. So I could go over 4 units. I could go over 8 units. I could go over whatever I want. We'll go over 4 units. So there's 4 units here. And then the rise is 5 units. So we have 4 units here. We have 5 units here. I'm actually looking for this little angle right here, which again would be the same as those other angles. And so this is the opposite side to that angle. This is the adjacent to that side of that angle. So then that means we're going to use tan. So tan of theta equals opposite over adjacent. Well, the opposite is the rise, and the adjacent is the run. So that means basically that for any problem, the slope is equal to the tan of theta. And that might be a little bit more important to you in a later grade, but it's good for you to see it right now. So tan of theta equals opposite, which is 5, divided by adjacent, which is 4. So theta, remember, we need to get the theta by itself. We don't know what theta is, so this is where we have to use that tan inverse. So theta equals tan inverse of 5/4. Now I just want to re-explain that again here, why that works that way. So tan of theta equals 5/4. So we want to isolate the theta. But to get that theta by itself, that means I need to get rid of the tan. And you don't get rid of tan by dividing. That's like getting rid of a square root by subtracting. You don't get rid of them that way. You do the opposite operation. So the opposite of tan is tan inverse. So then what I have, I got tan theta here, and I've got 5/4 over here. So I'm going to do the tan inverse of each side. And what happens is that tan inverse cancels out tan, and so then you're just left with theta equals the tan inverse of 5/4. Okay, I just wanted to explain that again. I know we've seen it before, but that's why it works that way. So I'm just jumping right from this line here, tan theta equals 5/4, right down to this line where theta equals tan inverse of 5/4. So to undo the tan, we have to tan inverse. So then you have to use the second function on your calculator, so don't forget to hit the shift. So shift tan, and then put that 5/4 inside brackets or it's not going to work. You got to use the brackets on your calculator, and that turns out that theta equals 51.3 degrees. Okay, so whether that angle is down here, whether we're talking about this angle down here, that's the same as this angle here. Okay, and that's it for that question.